So we're going to look at the Chromite mineralization and igneous stratigraphy of the Blackbird deposit in the Ring of Fire, Ontario, Canada. So this work is just a summary of a review that we did. We sort of recognized that we needed to improve our corporate understanding of the Blackbird intrusion. The latest work on it was done in 2012, so we needed to update that a little bit. So this is what that is. So Noront is an exploration company, so we may have forward-looking statements in this, just as a declaration for all those out there. The Ring of Fire is located about 520 kilometers northeast of Thunder Bay in Ontario. Our closest community to the Ring of Fire where we're working is Webequie First Nation. It's about 80 kilometers to the west with an all-season gravel airstrip, and from there we take a helicopter in. There's another community about 290 kilometers south of the Ring of Fire, Nikina, which has road and rail access. We also take float planes based from Nikina into the site. A little bit on the regional geology. The McFolds Greenstone Belt is a 2.7 greenstone belt. It's arcuate shaped. It extends for greater than 200 kilometers. And within it, there's a number of assemblages that have been subdivided. And the one that we're going to be focusing on is the Muckatai assemblage, as shown in the light beige, extending around the Ring of Fire. Within the Muckatai assemblage, there's a plethora of deposits. The most or best known is Eagle's Nest, the nickel copper PGE, and then also the chromite mineralization hosted in Blackbird intrusion that we're going to be looking at, and the Black Thor intrusion. There's also 3 VMS basins that are recognized, McFolds Basin, Butler, and 501, which host copper zinc exhalative mineralization. In addition, there is gold mineralization throughout the greenstone belt associated with structures. So we're going to be focusing on what's termed the central Ring of Fire, as outlined in the red square. And then this is just an aeromag or airborne total magnetic intensity map outlining the Esker intrusive complex. So it's been subdivided. This is the Black Thor intrusion, comprising of the Black Thor portion, Black Creek, and Big Daddy, named after the chromite deposits hosted within them. C6 is also termed Lobe 3, AT5. Eagle's Nest Dike, which hosts Eagle Nest deposit, is this small red mag response here. And the double Eagle intrusion is this portion down here comprising AT1 and Blackbird segment. And then there's another intrusion, AT3, sitting at the southwestern end of the greenstone belt. So this is what the geology looks like. We've got tonalite basement, and then we've got ultramafic intrusion sitting along that contact, and then supercrustals sitting in the hanging wall. So the interpretation is that stratigraphically these would have been sitting like this. And then this is the double eagle complex comprising AT1 in the footwall and Blackbird in the top. These two have been separated by a fault, by Frank's fault, and there's about 1.5 kilometers offset between these two bodies. But the interpretation is these would have been a whole intrusion. This is the interpretation or cartoon interpretation of what we're seeing. We've got a lower segment in the granodiorite, the AT1 segment. We've got Frank's fault that transects it. And we've got the Blackbird segment sitting on the top. We've got chromite accumulation occurring in the Blackbird segment, peridotite, proxenite, and gabbro, and then supercrustal rocks forming the hanging wall. So we're going to look at the chromite in Blackbird first. Chromite occurs throughout much of the intrusion. If we look at the assay data, we can see the range of cotectic chromite with olivine going up into disseminated, and then once we trend back into here, we're into massive accumulations of chromite. Where we see chromite in the Blackbird segment, there's one lens at the base called BB1. This one's a little bit different. It's got a very strong plunge control, and the interpretation is this is a channelized flow environment where we're seeing accumulation in a channel. The rest of the chromite that we're seeing is much more tabular and spatially extensive, forming sheets. The sheets aren't always continuous. They pinch and swell, they bifurcate, and then they sort of pinch out. The largest two, or the most significant chromite lenses, are the BB2-1 lens and the BB2-4 lens occurring at the top of the intrusion. The interpretation is these were laterally continuous at one point in time. They've just been structurally displaced from each other. So just a couple of photographs of what the chromite looks like. The top photograph in the left corner is the massive chromite from the BB2-1 lens. When I was logging, we were sort of looking at some of the otoliths in there. There's a small peridotite otolith contained in there. Not overly common, but not rare by any means. Another texture we're seeing in the lower right-hand side is the intercalated chromite seams within a peridotite. And finally, the top right photograph is more of a rare texture, retriated chromite otoliths within a peridotite. So some reworking of those chromite seams. There has been a historical resource produced, or resource estimate for Blackbird, with a measured and indicated of about 20 million tons at a grade of about 35% Cr2O3, and that was a 2012 resource. A fair bit of work has been done on looking at the chromite from various PhD and master's studies, and then also some in-house work. So this is microprobe work on the chromite. Just for reference, BB1 lens at the bottom, BB2-1 and BB2-4 are stratigraphically the highest lenses. What we see is a very consistent chromite composition. We do see some variability in iron. BB2-4 lens has higher iron, but that's largely attributed to more structural deformation and iron alteration probably associated with that lens. If we compare Blackbird to the other intrusions in the Esker suite, we've got the Big Daddy and Black Thor chromite lenses. Again, we see very consistent chrome compositions or chromite compositions running around the 48-49% Cr2O3 and fairly consistent chrome iron ratios of about 1.8, 1.86. There is some lens variability, but most of that's been largely attributed to alteration. So we're seeing very similar chromite compositions across the Esker suite of intrusions. So what does the chromite look like? This is just a photograph of the massive chromite from the BB2-1 lens, and then just the grade. So this hole intersected about 23 meters of massive chromite with a grade of 37% Cr2O3. And these are just examples of other intersections from that chromite lens. It averages somewhere between 15 to 20 meters of massive chromite, around that 35 to 42% Cr2O3. So going back to this, the highest grade chromite lenses and the most significant chromite lenses we see are occurring in the upper part of the intrusion. They're the last accumulation of chromite. What we see is a sharp contact. We have olivine cumulates in the footwall. We've got massive chromite sitting on top of them. So this is massive chromite again. Sometimes we get intercalations of peridotite and thin chromite seams within it, and then back into massive chromite. And the top contact is again very sharp, but overlying in the hanging wall is pyroxene cumulates. Alteration and deformation is usually fairly intense throughout these, and differentiating rock types can be a challenge. There's just some photographs of textures in better preserved sections. So we're seeing a peridotite, pyroxenite with some shearing, and then chromite peridotite with disseminated chromite interstitial, and then another peridotite. So based on the rocks, it looks like a lot of monomineralic mesocumulates and orthocumulates. So we started looking at the mineralogy, and with the chromite SEM and microprobe work that was done, a lot of silicates were also analyzed, and we're seeing three main silicate phases. We're seeing olivine, anstatite, and augite. So just a plot on iron versus magnesium. We're having olivine plot along an olivine control line. We're seeing a bit of a range from phosphorite 89, 88 down to phosphorite 80 or so. We're also seeing a bit of range in proxenite and augite. What we were surprised when we plotted up the assay database is largely based on ICP-MS, but we're not seeing a distribution in high olivine cumulates. We're not seeing any dunites. So the interpretation is that the rocks may appear monomineralic, but we're seeing a significant component of enstatite in these rocks as a mixture of olivine and enstatite with some augite. So if we look at the stratigraphy of the intrusion, this is based on portable XRF, and it's a composite of about 5 different drill holes through the stratigraphy, as not one single drill hole goes from top to bottom. And this is starting at the bottom of Frank's Fault and upwards. So there's also olivine cumulate in the AT1 segment also that isn't documented here. What we're seeing is a lower zone, which we've broken out based on sort of, it's got cotectic chromite abundances. We're not seeing a lot of chromite accumulation. The one exception to that is the BB1 lens that occurs at the base here, which is interpreted to be a channelized flow environment. We've got a middle zone, which is where we start seeing excess chromite accumulation with multiple chromite lenses, significant chromite lenses occurring. And the top of that unit or middle zone is defined by the BB21 and BB24 chromite horizon. Sitting above that, or hanging well to those chromite, is the upper zone, and the upper zone comprises of 2 units, a peroxenite unit and a gabbro, which sort of seem gradational with each other. The peroxenite is apparent in the portable XRF data as we sort of see a drop in the nickel. There's no longer any olivine in there, and then an increase in the silica. If we look at those relationships further down, we see similar associations with chromite lenses that aren't as significant. We're seeing a drop in nickel and an increase in silica. So there's a peroxenite sitting above that chromite lens also. And again, another lens that, or interval of lenses, a drop in nickel indicating peroxene and an increase in silica. So we're seeing a repeating pattern of chromite mineralization or peridotite, chromite mineralization, and then chromite mineralization is capped by peroxenite. When we move further up in the stratigraphy, when we transition from the peroxenite into the gabbro, so we're looking up stratigraphy or down stratigraphy now. So we're going from a peridotite leurzolite into the BB21 chromite accumulation, chromite lens. We go into the websterite, the peroxenite. We're seeing a drop in the nickel, very constant magnesium abundance, and then chromium tapers off. When we come out of that, we go into the gabbro, as we're seeing with an increase in aluminum, increase in calcium. But associated with that, is an increase in PGEs. We're seeing some stratobound PGE mineralization associated with the onset of plagioclase crystallization. The distribution of this isn't well documented, as it's trace sulfides. It's sort of less than 0.5% sulfur associated with mineralization, so it wasn't always assayed, and the importance of it wasn't recognized. So we're seeing grades up to 2.5, 3, 4, 5 grams platinum palladium combined over somewhere between 2 and 7 meters usually is what we're seeing. So if we compare the Blackbird segment that we just looked at to the Thor intrusion, Thor intrusion has had considerably more work carried out on it and established stratigraphy. It was recently published by Michelle Hoyle and others in 2012 in a Targeted Geoscience Initiative 5. They're seeing a lower peridotite, middle peridotite with chromite, and then sort of an upper sequence of peroxenite and gabbro, very similar to what we're seeing at the Blackbird segment. So these intrusions display considerable similarities. So conclusions, the Blackbird segment of the double eagle intrusion hosts multiple stratobound chromite layers, the most significant being BB21 and BB24, occurring in the transition from olivine cumulate to peroxene cumulate rocks. BB21 has a true thickness between 15 and 20 meters and continues along strike for 950 meters to a depth of at least 860. That's as far down as we've drilled, and it remains open. Chromite composition is characteristics that Blackbird are very similar to Black Thor and Big Daddy, suggesting similar parental magma composition and processes for chromite crystallization. What we've found is there's a significant component of orthoperoxene or enstatite present within the host intrusion. And the Blackbird segment is roughly divided into 3 stratigraphic sequences or series based on abundance of olivine chromite, coupled with large-scale onset feldspar crystallization. So that's the lower series, middle series, and upper series. And then the internal stratigraphy of Blackbird is broadly similar to the Black Thor intrusion. And then some references for the work that we pulled the SCM and microprobe data from. So thank you very much for your time.